This is the first lesson of Unit 1. Our first unit, we're going to be looking at the quadratic function. So you'll see on this first slide here, just some goals for our unit, basically just outlining what we're going to be working with. Notations that describe relationships, linear and quadratic functions, linear and quadratic relationships, and transformations. So the first topic that we're going to look at is the characteristics of a function. So again, our learning goal for this lesson is to identify the difference between a relation and a function. So we're just going to start with a couple of definitions here. So the first thing is a mapping diagram. So this is just a drawing with arrows to show the relationship between each value of x and the corresponding value of y. So if you look, this example here shows us what a mapping diagram looks like. So for example, let's say we have the set of ordered pairs 2, 8, 3, 5, 4, 1, and 5, 8. So a table of values, which is something we're familiar with and we looked at during our review, would look something like this T-chart, right? We have our x's on the left, our y's on the right, and we would just simply list the x's, list the y's, so that they line up with the corresponding values. A mapping diagram, on the other hand, as you can see here on the right, would look something like this. So instead of having just an x and a y, these arrows show what corresponding value of y goes with the x. So we can see we have 2, 8, 3, 5, 4, 1, and 5, 8. So we have two values going to 8, and we can see that simply because there's two arrows going there. So we'll look in a little bit why this is actually important, but first of all, you need to know what actually that diagram is and what it represents. So moving on now, another definition here. So set notation is a way of writing a set of items or numbers within curly brackets. So very, very straightforward here. You can see I provided you an example here. This is just saying that x is equal to 1, 4, 9, and 11. So these are just x values, and they are within curly brackets. Okay, now getting to the kind of the root of this lesson and the part that's going to be very important. I'm just going to see if I can find a highlighter here. I don't think so. I'll just underline. So the first thing is domain. Okay, so domain is the set of all values for which the independent variable, which is x, is defined. So that definition can be a bit confusing, but I'm hoping by the end of the unit you will understand what that means. But if you want to just make a note to yourself, all that definition is saying is the domain is all possible x values. All possible x values. Okay, so for example, we can write this in two different ways. So if we were given these points, which are the same points we see above there, there's two different ways we can write it. So the shorter way, the simpler way that most of you will probably choose, is to simply write, so you're going to put a D, because we're talking about domain, semicolon, or sorry, colon. Now those curly brackets come in, and all you're going to do is list the x values. So remember, obviously all of our points are x, comma, y. So we're just listing the first number in those coordinates. So it's going to be 2, 3, 4, and 5. So that's a really easy way to state your domain, okay? And that is, you're literally just saying these are the possible x values of this line or of these coordinates. The other way to write it, which is essentially the same, but it's just a notation that you're going to have to be familiar with. It's a bit longer, so I'm just going to start outside. You're still going to start with D because we need to know what you're talking about. you're going to put your curly brackets, and then you're going to write X, E like this, and an R. And what this means is X is any real number, or X is the real numbers, comma, and then you're just going to list them. X equals 2, 3, 4, and 5. So essentially the same thing, we just have this little notation here that makes it a bit different. And like I said, that's just a notation that you'll need to be familiar with, and you will learn a bit more as we go here. So the second big topic for this note is called range. So range is the set of all values of the dependent y variable. Okay, and just to simplify that for you again, all that means is all possible y values. All possible y values. Okay, notation is essentially the exact same, except now we're talking about range. So we're going to put R colon, sorry, I keep trying to call them semicolons. R colon, this time we're going to write Y, that little E symbol, R. So Y is the numbers, is essentially what that means. And then we're simply just going to list our Y values. So in this case, we have, I'm just going to write them in order. So it'll be 1, 5, and 8. And we only have 3. We're not going to write 8 twice because we already have 8 in there. There's no point in writing it twice. Okay, and I just got those from these y values here. Okay, and then the simpler version of that, R colon, set notation, right? Those brackets are important. 1, 5, 8, and close your curly brackets. Okay. So moving on here, I just have to pull up the next part of the lesson. Perfect. Awesome. So now we are going to look at real numbers. So this is where that XER comes in, and this is the explanation for it, basically. So the set of real numbers is the set of all decimals, positive, negative, zero, terminating, and non-terminating numbers. Okay? So real numbers are all numbers, essentially. Okay? So the statement is expressed mathematically with the set notation XER. Okay, so XER represents the sentence above. So the set of real numbers is essentially what it means. Okay, and I'll underline that for you. I'll try my best anyways. Okay, so XER is the set of real numbers. So as you can see, the next line, it just repeats that. X means X belongs to the set of real numbers. So if our variable has no restrictions, then this is the notation that we're going to use to describe exactly that situation. So for example, if we have a line, and we'll look into some examples, but if we have a line, okay, pretend it has arrows on the end, or actually maybe I can draw some arrows on the end. Arrow, arrow. So this line is just going to keep going up, down, okay? It's just going to continue going. So that means that every single one of these x values, right? This is our x, this is our y. Every single one, of these x values, whether it's a decimal, a fraction, a whole number, they all have a point on the line, right? We can see that if I extended this pink line and kept drawing these green lines, I would always be able to find my pink line. Okay, I would always be able to touch it. Same thing on my y-axis. So if I go from my y, okay, these lines I'm drawing, they can be from any number. Like this could be 10.662 blah, 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 right? Continued, it's still going to be able to find a point on the line. You're still going to have an x value for that given y value. Same thing down here, right? I can draw lines and I'm always going to touch that line. So I know this concept is kind of confusing, but just bear with me. I'm hoping that the rest of the note will help you better understand. Okay, so before we actually get into some examples, I want to just give you some definitions of some symbols that you might see. Okay, so inequality symbols. Again, you're going to know what these mean, or you really should know what they mean. I'm hoping this is just a reminder. Obviously, that equal sign means equals. We have the greater than sign, less than sign. When there's a line underneath of those greater than or less than, that means it's greater than or equal to, right? It kind of combines the equal sign with the greater than or less than sign. So this is why this is important. So if we have this open dot, one second here. Okay, so open dot is the same as greater than or less than. So here is an open dot. Okay, so that means if we're looking at this top line, so we have 5, and then it's going towards x. So how we would write this is x is greater than 5. Okay, it's not greater than or equal to because the dot isn't filled in. Okay, which means that when we use greater than or equal to, that's a closed in dot. Okay, so if this line is just continuing, we're calling the line x because we're on the x-axis here. If it were to just keep going, that means that the x values are greater than 5. Okay, on the other hand, if we have this closed dot, like I said, if it's a closed dot, that means greater than or equal. That means there's a point on 5. Okay, this one here, the top one, there's no point on 5. The line doesn't cross 5, but here it does. Okay, it actually starts at 5 and it's going to continue till infinity. So how we write that is x is greater than or equal to 5. Okay, so those are the simpler versions. If we look at this next one, it gets a little bit more confusing. This is something that we call a dual condition. Dual condition. Okay, so we have two conditions here. Okay, the first is that x is greater than or equal to -5, right? It's greater than because it's moving to the right. Think about that line on a graph. And it's greater than or equal to because we have that filled in circle. Our other condition though, so basically think about this line as between -5 and 7. So we need to know what values are between -5 and 7. And this is how we're writing this. Instead of just listing them out, this is our way of writing it. So our other condition here is x is going to be less than 7, right? It's not less than or equal to because we have the open circle. So basically this is saying that x is between -5 and 7. So how we would actually write that, we're going to put an x in the middle. Okay, our signs are always going to go to the left. And I'll explain why in a second. So we're just putting these two things together. So on the left-hand side is going to be your lowest number. Okay, and I see that, that it's actually equal to -5. So I'm going to just add in that line. And then here on the right side is going to be your highest number. So now when I read this from the center out, we have to make sure it's saying the same thing as what it says above. X is greater than or equal to -5 and x is less than 7. So we read it from the center here. So x is greater than or equal to -5, perfect. and x is less than 7. Okay, so you can see that we can simply combine those two conditions in a very, very comprehensive way. And so let's look at a couple more examples here. I'm going to go back to the color I started with. So it's asking us to state the domain and the range for each. So we can see, similar to that example I gave above, that this is just going to be a line that continues to infinity, both directions. Okay, so that means there's actually no restrictions. No restrictions. So how we write that, hopefully you remember, domain, colon, bracket. Okay, x is equal to all real numbers, right? There's no specific numbers that it's equal to all of them. That means for any x value here, it will have a y value. Okay, same thing with the range. So again, writing r, colon, squiggly brackets. In this case, range is dealing with the y-axis. So we're going to write y is equal to all real numbers. That means for every single value of y, you will have an x value. So that's like the easiest case scenario, right? There's no restriction, so I just have to remember these two things, which is really just one thing, and changing the x and y so that you're using them correctly. For the domain is always x, the range is always y. Okay, let's look at a little bit more of a tricky example here. So we look at this graph. First, we're going to look at the x-axis, okay, which is the domain. So always just start with the domain to make it easier for you. You know this is the form you're going to have to use, so you can start by just doing that. So we're looking at the x-axis. Domain is the x-axis. So I see on my x-axis that my point is starting, oops, that's not what I wanted to do, at 4. Okay, and the reason I know that, that's a very bad line. Try one more time. That's even worse. There we go. So if I look where my line is starting, I'm just going to draw a line up to the x-axis to see where it's starting. And it's clearly starting at 4. Okay, so my line is going out until the right, out and to the right. So I can see that it's getting larger than 4. So how I would write that is x is greater than or equal to, right? That's a filled in dot, 4. That means for any value of x that's 4 or larger, there's a corresponding y value. Okay, the range on the other hand here, we have to look at the y-axis. Okay, the y-axis, I'm going to do the same thing. I'm just going to draw a line to see where I'm starting on the y-axis. Okay, and these graphs only give us one number, so we kind of know, but in most cases it'll just be on a normal Cartesian plane, so you'll have to draw that line to see where it's starting. So this line is starting on our y-axis at -6, and it is going down. So that means that y, whoa, oh no. Sorry. So y, here we go. Okay, so domain, we're on range. So y here is going to be less than or equal to -6. The reason that it's less than is because it's going down. Think about it if this y-axis was continued. These numbers would get smaller, right? -7, -8, -9, -10, etc. They would continue getting smaller, so we know that our range has to be less than or equal to negative 6. And our domain here was x is greater than or equal to 4. And the reason, again, it's greater than is because if you look at the direction the line's going, that's going to continue down your x-axis to the right, which means your numbers are getting larger. All right, next example. So here we have a line that has a start point and an end point. So we know this is going to be one of those dual conditions. Okay, so same thing though, we're still just going to start with our domain. Okay, and because it's a dual condition, you might want to even go like this. Put your x in the middle, because you know there's going to be a condition on one side and a condition on the other. And you know your arrows have to point to the left. Okay, this first value is going to be our smallest value. So on our x-axis here, so try to just isolate the x-axis, ignore the y. So we're starting at negative 5 and we're going to 7. Okay, so my smallest number is negative 5 and my largest number is 7. But remember, just double check here, because this is a filled in circle, we're just going to add the greater than or equals to sign there. Okay, your range is going to be the exact same thing, except now we're looking just at the y-axis. So you can go ahead, start like this. It'll help you out a bit. So we know that on the left has to be our smallest y value, and on the right has to be our largest y value. So again, I'm looking now at the y-axis, so try to ignore x completely. So I see my line starts at negative 6, and it goes up until 9. Okay, so my lowest number out of those two is negative 6, and my highest is 9. But again, remember this one side is filled in, so I'm just going to add the equal sign to that greater than sign. Okay, and remember to check these dual conditions. All we have to do is read from the center out to make sure it makes sense. So y is greater than or equal to negative 6. Yep, it's greater than, right? The line is above negative 6. And y is less than 9. Correct. The line is only below 9.